Chapter 7, Day 1, Learning Targets A and B. We're going to simplify expressions with negative and zero exponents. So this might be new for you. And evaluate the same type of expressions. So, if you simplify each expression, x plus x plus x plus x plus x is equal to 5x's. So that's equal to 5x. So a coefficient represents repeated addition. So here's your coefficient. That means repeated addition, you're adding x 5 times, or 5x. X times x times x times x times x is x multiplied 5 times. So an exponent represents repeated multiplication. So sometimes those can get confusing, and so you need to be able to keep those two things straight. So repeated addition is a coefficient. Okay? On the other hand, repeated multiplication is an exponent right here. So let's take a look at a few of these examples. If you have 3 to the 4th power, what we're really representing there is 3 times 3 times 3 times 3. And if you wanted an actual value for that, that would be 81. Okay, 7 times 7 times 7, that's 7 to the 3rd power. And of course, you could use your calculator to get a value for that. But what I'm really trying to show you here is what 3 to the 4th power means and looks like, what 7 to the 3rd power means and looks like. And so then when you get variables, if you have y to the 8th power, that's y multiplied 8 times. And so x to the 2nd, y to the 3rd would look like x multiplied twice and y multiplied 3 times. So just keep that in mind as we're working through these properties of exponents and how they work. So let's take a look at this example. See if you can stop and fill in at least these first 3. What is 2 to the 3rd power? Well, it's 2 times 2 times 2, but what does it equal? Pause the video for a minute and see if you can fill those 3 in. Well, 2 to the 3rd power is 8. It's not 6. It's not 2 times 3. It means 2 times 2 times 2. 2 to the 2nd power is 4 because that's 2 times 2. 2 to the 1st power is just 2. So notice each time that we go down, we are multiplying by 1 less 2. So if you take a look at this pattern a little bit more closely, when you are going from 8 down to 4, okay, and 4 down to 2, what you're really doing is you're dividing by 2. If you're going from 2 over to 4, now you're multiplying by 1 more power of 2, okay? So that's the difference between whether you're going up in the pattern or whether you're going down in the pattern. Because here we're multiplying by 1 more power of 2. And on the right side we are dividing. So using that idea, if we take 8 and we divide it by 2, we get 4. If we take 4 and divide it by 2, we get 2. So what happens when we take 2 and we divide it by 2? Well, we get 1. So 2 to the 0 power is equal to 1? Really? No, that's true. Really, that is exactly true. So anything to the 0 power is always going to be 1. So that's the first thing that we're going to be looking at, is anything to the 0 power is always going to be 1. Now, this is trying to help show you why. But what about if our exponent is negative? Now what? Well, continue this pattern. If I take 1 and I divide it by 2, what I get is 1 divided by 2, or 1/2. And of course you could use it as 0.5, okay? And that would be the same. But we aren't going to be giving our answers in decimal form. So if you typed in 2 to the 3rd power on your calculator, you would get 8. If you typed in 2 to the 1st power, you'd get 2. And if you type in 2 to the 0 power, you will get 1. But 2 to the -1 power on your calculator would give you 0.5, which is 1/2. And we are going to give all of our answers in fraction form. And the other thing to keep in mind is what happens when we get variables. So let's keep going here, and let's see what happens now if I divide by 2 again. Okay, because that's what's going on. When you have 2 to the 3rd power, it means 2 multiplied 3 times. And when you have 2 to the 2nd power right here, what it really means, what 2 to the -2 power means, you're taking 2 and you're dividing by 2 twice. And so what this is going to become is if you take 1/2 and you divide it by 2, remember, keep, change, flip, and this becomes 1/4. And if you divide by 2 one more time, again, if we work this out on the side, if we take 1/4 and we divide it by 2, we keep, we change, and we flip, and this becomes 1/8. So what we're doing is we're dividing by 2 3 times. And that's what happens with negative exponents. And what we could further do is look at this as 2 to the -1 is 1 over 2 to the 1st. 2 to the -2 is 1 over dividing by 2 twice. And 2 to the -3 is 1 over 2 to the 3rd, because we're dividing by 2 3 times. So that's the pattern, that's the relationship of positive, negative, and 0 exponents. And here's why we can't just plug these things in our calculator, because we are going to be working with variables, 2, positive, negative, and 0 powers. So again, if we look at x to the 3rd power, that's x multiplied 3 times. X to the 2nd power is x multiplied 2 times. X to the 1st power is x. Notice, as you go down in this pattern right here, you are having 1 less power. Or really, what you're doing is you are dividing by x. To go down, you're dividing by another x. So x divided by x gives us our 1. So again, as I said before, anything to the 0 power is always going to have a value of 1, whether it's a number or a variable. Okay, so again, if we keep going with this pattern of dividing by x, there's 1 less x. 1 divided by x is 1 over x. Divide by x again, and you're dividing 1 over x and x. You're dividing by x twice, or 1 over x to the 2nd. And can you fill in the last one just by looking at the pattern? Well, your answer should be 1 over x to the 3rd. So what happens here with negative exponents is that negative exponents wind up on the bottom of the fraction as a positive value. And those are sort of our 2 properties in this lesson. So, if we consider the expression a to the n power, if n is a positive integer, then that means a multiplied n times. If a is non-zero, then in other words, 0 to the 0 power, what is that? That's just 0. But a to the 0 power, if a is anything other than 0, then anything to the 0 power is 1. And again, anything to the 0 power, any expression, any number, any letter raised to the 0 power will always be 1. So let's take a look at these examples. What is 7 to the 0 power? Anything to the 0 power is 1. So 7 to the 0 power equals 1. What about 23rd to the 0 power? Well, that's also 1. Well, what if you had 2.75x raised to the 0 power? That would still be 1. So keep that in mind as we move forward throughout this lesson. If n is a positive integer, then again, any next negative exponent, okay, becomes a positive exponent on the bottom of the fraction. So if n is a positive integer, so 2, if you have a to the negative 2, that would be like saying if we have a to the negative 2, then that becomes 1 over a to the positive 2. So 7 to the negative 2 becomes 1 over 7 to the second power, which is 1 over 49. X to the negative third power is 1 over x to the positive 3. So a simplified expression, when you simplify, should never contain negative exponents. They need to be put on the bottom of fraction as a positive because you are not multiplying by x 3 times, you're dividing by x 3 times. All right, so I'm going to work through a few of these and I'm going to have you try a few of these as we go through this lesson. So 3 to the negative 4 power. Not multiplying by 3 4 times, we're dividing by 3 4 times. So that becomes 1 over 3 to the 4th power. Well, 3 to the 4th power is 3 times 3 times 3 times 3, so that's 1 over 81. Now, number 2 and 3 look very similar, okay? But you have to be careful because this number 2 is saying to take the opposite of 4 to the negative 2. Well, 4 to the negative 2 is 1 over 4 to the second, but I'm taking the opposite of that, so that's going to be 1, it's going to be the opposite, so negative 1 over 4 squared, or negative 1/16. Now, if you compare that to the one below it, here you are taking this whole expression to the negative 2 power, so this is going to become 1 over negative 4 to the positive 2. And that's going to become 1 over negative 4 times negative 4, which is positive 16. And now we combine variables and letters, but remember this just means multiply in between. So this is 2 times 1 over x to the third. So now we just multiply those together and that becomes 2 over x to the third. Let's take a look at this one. You have to take each of these pieces separately. This is 5 times x to the negative 1. That becomes 1 over x to the positive 1. And then again, this is times y to the negative 3. That's 1 over y to the third because we're dividing by y 3 times. And then finally we have times z. So now what we need to do, remember with our properties of multiplying fractions, we put a 1 under on the whole numbers, and now we multiply the numerators. So 5 times 1 times 1 times z is 5z. Then we multiply 1 times x to the first times x to the third times 1, and that's x, y to the third. All right, let's see if you can try this last one on your own. Give it a try. Remember, there's multiplying in between each one of these. So do what we did in number 5, write each of the pieces out separately, and then multiply the fractions back together. Pause the video and see if you can get this correct. If you got the right answer, you should have 3 over y to the fourth. Now, if you didn't get that, here's what happens. You're taking 3 times x to the 0. Well, anything to the 0 power, remember, is 1. Times y to the negative 4 is dividing by y 4 times. So 1 over y to the 4th. Now we multiply all these together, and 3 times 1 times 1 is 3 over 1 times y to the 4th is y to the 4th. Okay, so hopefully some of these examples and going through them are starting to make a little bit more sense. And the last piece we're going to work on is evaluating expressions that have negative and 0 exponents in for certain values. So this is just like we've been doing before. If we know what x equals, we're going to put it in here for x. So this becomes 4 times, and then we're going to take 2 and raise it to the negative 3 power. Remember, that's dividing by 2 3 times. So this is going to become 4 times 1 over 2 to the 3rd. And again, multiply these together as fractions, and you get 4 over 2 to the 3rd. Well, 2 to the 3rd is 8. 2 times 2 is 4, times 2 is 8. And so this final answer becomes 1/2. All right, you try the next one. You see if you can substitute this value of x in for x. Follow the same steps we did above and see if you can get the final answer. Pause the video and then restart to see if you got it correct. Okay, so we follow the same exact steps we just did, and we substitute in 4 for x, and that gives us 4 to the negative 3. So now we have 4 times 4 to the negative 3, which is 1 over 4 to the 3rd, because we're dividing by 4 3 times, which gives us 4 over 4 times 4 is 16, times 4 more is 64. So now we reduce that fraction, as we always do, and 4 goes into... well, we could reduce it in half first, which would give us 2 over 32, but then we could reduce it again to 1 over 16 would be our final reduced answer. Okay, we have one more to do, and this is kind of a preview for tomorrow. Well, what would we do if we have 1 over x to the 3rd? Well, let's think about this. This would be 1 over, and then the x to the 3rd part would become 1 over x to the 3rd. So x to the negative 3 becomes 1 over x to the 3rd. Well, now we have a number divided by a fraction. So again, going back to our rules of fraction, this becomes 1 divided by 1 over x to the 3rd. And what do we do with fractions? We keep, we change, and flip. So this actually becomes 1 over 1, or 1 times x to the 3rd, which is x to the 3rd, over 1, or simply x to the 3rd. And we'll get into more of that tomorrow. That's our first lesson in chapter 7 for learning target.